Imagine a photograph so strange, so unexpected, that it stops the world in its tracks, not from a cutting-edge telescope, not from a rover on Mars, but from a spacecraft launched nearly half a century ago, now drifting over 15 billion miles from home. Voyager 1, humanity's farthest explorer, has just sent back a brand new image from the edge of our solar system, and it's unlike anything we've ever seen. This isn't just a blurry snapshot of stars or a faint smudge of light. It's a cosmic puzzle, a glowing, intricate web of light and shadow that's left scientists, engineers, and dreamers across the globe scrambling for answers. In the next few moments, you'll discover exactly what's hiding in this otherworldly frame, why it's sparking heated debates, and how it might rewrite everything we thought we knew about the universe. Buckle up, because this is no ordinary space story. This is a mystery that's gripping the planet, and it's about to pull you in. Let's set the stage. It's April 2025, and NASA's Jet Propulsion Laboratory drops a bombshell. A fresh image from Voyager 1, captured at the heliopause. The boundary where the sun's influence fades and the vast interstellar void begins hits the scientific community like a thunderbolt. At first, the raw data looks like static, a chaotic mess of green, purple, and white pixels scattered across a black canvas. To the untrained eye, it's just noise, the kind of glitchy feed you'd expect from a 48-year-old probe, pushed to its limits. But then, something extraordinary happens. Researchers apply advanced machine learning algorithms trained on decades of space imagery from missions like Cassini and New Horizons to clean up the noise. Slowly, pixel by pixel, a structure emerges. Not a planet, not a star, but a sprawling, luminous network of filamentary tendrils stretching across the frame like glowing veins of cosmic plasma. It's as if the universe itself has painted a masterpiece at the edge of our solar system, and Voyager 1, against all odds, has captured it. This isn't the pale blue dot, that iconic image of Earth as a tiny speck in the cosmic ocean. This is something far wilder. A radiant tapestry that seems to trace invisible forces, perhaps magnetic field lines or streams of interstellar dust, woven together in a dance of light and energy. The shock deepens when scientists realize this structure wasn't visible in Voyager's earlier images of the region taken over a decade ago. Something has changed out there, 15 billion miles away. And it's not just a static scene. The image correlates with spikes in Voyager's plasma wave detectors and cosmic ray sensors, hinting at dynamic, living processes at the boundary between our solar system and the galaxy beyond. This is no ordinary photograph. It's a window into a turbulent, electrified frontier where the sun's breath meets the winds of distant stars. To understand why this image is sending shockwaves through the scientific world, let's rewind to Voyager 1's origins. Launched in 1977, this scrappy probe was designed to explore the outer planets Jupiter, Saturn, Uranus, Neptune. It was a marvel of its time, carrying just 68 kilobytes of memory and a transmitter weaker than a kitchen light bulb. Yet, it exceeded every expectation, delivering jaw-dropping images and data that rewrote textbooks. After its planetary tour, Voyager didn't stop. It kept going, drifting toward the edge of the heliosphere, the bubble of solar wind that surrounds our system. In 2012, it made history again, becoming the first human-made object to enter interstellar space. Since then, its instruments have been our only direct window into this uncharted territory, measuring plasma, cosmic rays, and magnetic fields. But its cameras, they were thought to be long retired, switched off to save power for the probe's dwindling energy reserves. That all changed last year. In a daring move, engineers sent new commands to Voyager, waking its imaging system from a decades-long slumber. Using updated software and ultra-long exposure techniques, they coaxed the probe to take one final photograph before it drifts too far to communicate. The result? A composite of over a dozen exposures, each lasting hours, stitched together with cutting-edge denoising tools. What emerged is this haunting image of the heliopause, a region once thought impossible to visualize. And within it lies a mystery that's keeping the world awake at night. So what exactly are we looking at? Scientists are racing to explain the glowing filaments that dominate the frame. One theory suggests these are magnetic field lines, twisted and braided, where the sun's magnetic influence collides with the interstellar medium. Charged particles spiral along these lines, emitting faint light as they dance through the void. It's a cosmic light show, visible only because of Voyager's long exposures and our newfound ability to filter out noise. Another idea points to interstellar dust, tiny grains smaller than a speck of sand that become electrically charged as they cross the heliopause. When these grains collide with solar wind particles, they glow faintly, creating a shimmering veil that Voyager's cameras just barely caught. Both theories are grounded in physics, backed by Voyager's sensor data, and fiercely debated in top journals like Nature and the Astrophysical Journal. But there's a third, more provocative possibility that's setting the internet ablaze. What if these filaments aren't just plasma or dust? What if they're a clue to something far stranger, like dark matter? Some theorists propose that the heliopause, with its intense magnetic fields, could be a natural laboratory for exotic particles. One candidate, called axions, might convert into photons under the right conditions, producing faint light exactly where Voyager is looking. If true, this image could be the first visual hint of dark matter interacting with the universe we can see. It's a long shot, but the mere possibility has sparked a frenzy of speculation, from university labs to online forums. Peer-reviewed papers are already circulating, and the debate is only heating up. This isn't just science, it's a global obsession, and it's easy to see why. But the mystery doesn't stop there. As researchers dug deeper into the image, they uncovered something even more bizarre: a repeating hexagonal pattern embedded within the filaments. It's subtle, almost invisible at first, but statistically undeniable. Hexagons aren't unknown in nature. Saturn's North Pole has a famous hexagonal storm, but at the heliopause, on scales spanning billions of miles, this is unprecedented. Stranger still, the hexagons align with Voyager's spin axis, not with any known magnetic field. Is this a quirk of the probe's aging cameras, or is it real? A cosmic honeycomb woven into the fabric of the interstellar frontier. Some scientists wonder if these are magnetic reconnection zones, where field lines snap and reform, creating stable hexagonal cells. Others suspect a plasma instability, a ripple in the electrified gas that forms patterns we've never seen before. Whatever it is, it's not in our models. It's not in our textbooks. It's a riddle that's rewriting the rules of astrophysics. Picture it, a glowing lattice, stretching across the edge of our solar system, pulsing with energy and secrets. This isn't just a pretty picture, it's a challenge to everything we thought we knew. And it's not just scientists who are captivated. Across social media, from X to Reddit, people are sharing theories, memes, and wild speculations. Could these hexagons be the work of an alien civilization? Some vast, Megastructure harvesting energy from the heliopause. There's no evidence for it, but the idea's too tantalizing to ignore. Others wonder if we're seeing the universe's code, a glitch in the simulation, a hint that reality itself is a construct. These ideas are fringe, but they show how deeply this image has gripped our imagination. It's not just data. It's a spark for wonder, fear, and endless possibility. Now let's dive into the latest twist. Just weeks after the image was released, a team from the European Space Agency threw another curveball. Using their own quantum-assisted imaging tools, honed during the New Horizons mission, they reprocessed Voyager's raw data. What they found stopped them cold. A second filament, fainter and broader, tilted at a precise 60 degrees to the first. At first, they thought it was noise, a ghost in the data, but multiple analyses confirmed it was real. When they mapped both filaments onto a model of Voyager's field of view, something astonishing emerged. The two sets of filaments formed a pattern. 12 radial lines, like the spokes of a wheel, one set sharp and bright, the other faint and ghostly. It was as if the heliopause was a cosmic clock, ticking with a rhythm we'd never heard before. This wasn't a fluke. The symmetry was too perfect, the angles too precise. Researchers speculated that this could be a magnetohydrodynamic resonance, a kind of cosmic vibration where the solar wind and interstellar medium oscillate together, like a bell ringing across the void. One physicist described it as the heartbeat of our solar system, a pulse we're only now detecting. But here's the kicker. Nothing in our current models predicts this. Not the Parker spiral, not the heliosheath, not even Voyager's own data from a decade ago. This wheel-like pattern suggests the heliopause isn't just a boundary, it's a dynamic, structured zone, alive with forces we don't yet understand. It's as if our solar system doesn't just end, it sings. This discovery is more than a scientific breakthrough, it's a wake-up call. For decades, we've modeled the heliopause as a fuzzy, turbulent region, a place where the solar wind slows and scatters. But Voyager's image paints a different picture, a realm of order, symmetry, and beauty. The glowing filaments, the hexagonal lattice, the cosmic spokes, they're not random. They're part of a larger architecture, a tapestry of plasma, magnetic fields, and perhaps even exotic particles. And Voyager, with its ancient technology and fading power, has given us the first glimpse of it. This isn't just about one image, it's about redefining how we see our place in the cosmos. Let's talk about what this means for science. For plasma physicists, this is a goldmine. The heliopause is a natural laboratory for studying how magnetic fields interact across vast distances. The filaments and hexagons offer direct evidence of processes we've only simulated in computers. Magnetic reconnection, plasma instabilities, maybe even dark matter interactions. For astrophysicists, it's a chance to rewrite heliospheric models, to account for structures and resonances we didn't know existed. And for engineers, it's a testament to the power of ingenuity. Voyager's cameras weren't designed for this. They were built for Jupiter's moons, not interstellar frontiers. Yet with clever software and relentless determination, we've turned a 1970s relic into a cosmic artist. But the impact goes beyond labs and equations. This image taps into something primal, something that stirs the soul. Remember the first time you looked at the stars and felt small, yet part of something vast. That's what Voyager's image does. It reminds us that the universe is alive, pulsing with mysteries we're only beginning to grasp. In a world of fleeting trends and endless noise. This is a moment of clarity, a reminder that we're still explorers, still capable of wonder. Social media is buzzing with reactions, from awestruck posts on X to viral videos breaking down the science. People aren't just talking about data. They're sharing dreams, fears, and questions about what lies beyond. And that's where the emotion kicks in. Voyager 1 isn't just a machine. It's a piece of us. It carries a golden record, etched with our music, our languages, our hopes, a message to anyone who might find it. Launched in an era of bell-bottoms and disco, it's outlived its creator's wildest dreams, traveling farther than any human or probe before it. Now, nearly 50 years later, it's still speaking, sending us a message not from another civilization, but from the edge of our own. This image isn't just pixels. It's a love letter from the cosmos, written in light and plasma, delivered by a probe that refuses to quit. Let's zoom out for a moment. Exploration has always been about pushing boundaries, sailing across oceans, landing on the moon, roving Mars. But Voyager shows us a different kind of exploration, one that doesn't require speed or shiny new tech. It's about patience, about looking again at old data with fresh eyes. The heliopause was once invisible, its signals dismissed as noise. Now, with modern tools and relentless curiosity, we're seeing it for the first time. This is a lesson for our time. The universe doesn't reveal its secrets easily, but if we keep listening, keep tinkering, keep dreaming, it will speak. The questions raised by this image are as thrilling as the answers. If these structures, filaments, hexagons, spokes, exist at our solar system's edge, do they surround other stars? Is this a universal feature, a cosmic signature where stellar winds meet the galaxy? Or is it unique, a quirk of our sun's magnetic personality? And what happens next? If we turn our most powerful telescopes, James Webb, the Vera Rubin Observatory, or future interstellar probes, toward the heliopause, will we see these patterns more clearly? Could we map them, predict them, understand their rhythms? More tantalizingly, could these structures hold information? Not alien messages, but the kind of information that defines the universe. Patterns, symmetries, laws we've yet to discover. The universe, after all, isn't just matter and energy. It's a vast web of information, and Voyager has just handed us a new thread to pull. This image is an invitation, a call to keep exploring, to keep asking questions. Voyager 1, drifting silently in the dark, has done what no other mission could. It's shown us that the edge of our solar system isn't an end, but a beginning. It's a frontier, not of emptiness, but of structure, beauty, and mystery. And it's up to us to follow where it leads. As we stand on the brink of this new chapter, let's reflect on Voyager's journey. Built by human hands, powered by human dreams, it's carried our curiosity farther than we ever thought possible. Its golden record was a message to the stars, but this image is a message to us, a reminder that the universe is vast, strange, and still full of surprises. From glowing filaments to cosmic hexagons, to the spokes of a celestial wheel, Voyager has given us a glimpse of something profound. The hidden architecture of the cosmos sketched in light at the edge of everything we know. This is more than a scientific discovery. It's a moment that unites us. Across the globe, people are looking at this image and feeling the same awe, the same hunger for answers. Scientists are scribbling equations, coders are tweaking algorithms, and everyday dreamers are staring at the stars, wondering what's out there. Voyager 1, our farthest traveler, has whispered a secret from 15 billion miles away, and the whole world is listening. The question now is, what will we do with this gift? Will we chase the mystery, build new probes, ask bolder questions, or will we let it fade, another fleeting headline in a noisy world? The choice is ours, but one thing is clear. Voyager's story isn't over. It's still out there, drifting, watching, waiting. And as long as we keep listening, it will keep teaching us. This image, with its glowing tendrils and cosmic rhythms, is a testament to what we can achieve when we dare to explore, when we refuse to give up, when we believe the universe has more to say. So take a moment, look up at the sky, feel the weight of 15 billion miles and the lightness of a single photograph that's changed everything. Voyager 1 has shown us the edge of our world, and it's more beautiful, more mysterious, and more alive than we ever imagined. Thank you for joining us on this journey through the wonders of space. Your support makes it possible to continue sharing the marvels of the universe with the world. We can keep exploring the stars and uncovering the secrets of the cosmos. Until next time, keep looking up.